I need a USB A to C adapter.
No. Show me. No.
You need a USB A to C adapter, or Sue, if you have a USB A, could you drive the slides?
Hang on.
So I'm going to stop sharing. So pre-shared slides on the left-hand side. Oh, left-hand side. Kayer says I should be able to do this. So, if you pass it back, I'm happy to do it. If it doesn't load, that might be the case.
Good.
We'll find out.
Keyboard setup. You may have to turn it on.
That's what we're looking for.
Yeah, right there. Try on this side, see if it works. Yep.
So let us get started. Ready? All yours. Okay. Start up here. Good afternoon, everybody. This is IDR. Let's settle down and get started. We have a tight agenda, so we'll be moving very, very quickly. We are going to start by reminding you, you're in a nice, lovely, big room, and we would like to continue to get nice, lovely, big rooms. We will have this being passed around, but that said, the screen over there has the exact same information. Please use the light tool to actually sign in. I'll pass this around and get started with our lovely AD to get it started. There's many things that's lovely about you. Okay, so we're going to very quickly hit through the high points of things and start moving into our presentations just to try to be respectful of people's time slots. This is IETF. There is a note well. You all have expected to have read this at some point. Please do so at your own leisure, but you are bound by it if you are in this room. Please pay special note that the code of conduct is a thing you should be aware of, as is the intellectual property stuff. And the note really well tries to talk here about what the social contracts are that we're trying to maintain. In general, be graceful, don't be a dick. And we see that the technology is working exactly as well as it often does. Interesting. Unstable connection to server.
There should be a wired cord shielding from you. If you're on IETF Hotel, switch to IETF something else, Legacy or something else. IETF Hotel.
Okay, we're going to pause to get off the wireless. Be right back. The wireless is not working well.
We'll find out.
And this connector may be problematic.
There you go. Fine.
I see blinkies. Okay, restarting. Almost ready. We are still working through note wells. Where's the clicker? Is it down just a second ago?
Is it in your pocket?
Yep. Okay. When else fails, plug it back in. So meeting tips, please get onto the chat via the light tool if you have it. You can also use the Zoom client in your pocket. Resources for San Francisco, including reporting issues, which we almost had to do. Thankfully, that was not the case. We're going to very briefly go over working group status. So we've had a reminder from our area director that the ISG will be treating the 5-author limit on RFCs and internet drafts seriously. You've started seeing the chairs remind you of this at document adoption time. So please be mindful of that. The BHP Yang model is finished working group last call. We're waiting for implementations, so that's moving along. CAR and CT are in last call. We'll be talking a lot about that today. So there'll be a separate set of slides covering this specific point. The SRV6 policy document, the Shepherd review is done. We should have that going to the ISG briefly. A couple of things that we'll need to be dealing with. So the authors of the IPVPN internetworking draft, we'll discussing that with the authors about the DPath issues. This is also going to touch on things discussed tomorrow as part of the attribute escape stuff. So please pay attention to that tomorrow. And we will be having some discussions about link bandwidth. This is covered partially in the best document covering unequal load balancing. The chairs are aware of work that is trying to address the fact that we have 2 flavors of link bandwidth floating around. Reshma, if you could wave your hand just to catch people's attention, is one of the people at the Juniper side of things trying to help clean this up. Satya, I believe, is helping us at the Cisco side of things. So we should expect that there might even be an interim, covering this as a detail because it's a topic of interest, and interop is sort of interesting. In the area director queue, the segment routing policies is floating through there. There is some concern about the unimplemented types. There will be a discussion about what to do about them, which may include just simply pulling the types that do not have coverage in the implementation report from the core document into a separate document. Please watch for discussion about that on the list. Very similarly, we have the wide containers attribute as well that has the RPD stuff. There's some discussion about maybe doing a structural split about the container and the Y community itself, and what we do about the atoms. Again, please see this discussion that's moving on. Ketan, did you want to jump in quickly?
Ketan Talaulikar, Cisco, as editor of the BGP SRT draft. So, do I understand this as a requirement for every bit and TLV in a IDR working group document to have implementations? Is it like a general policy change, or?
We do seem to be pushing that general direction in terms of the document. We have a tension between wanting to document things that we know are useful for the future. We don't have a lot of time for discussion, so I'm going to encourage that we can finish this on the list. But this will be part of the discussion about what we want to take up as policy versus document by document basis.
Okay, thank you.
So also in the queue is the RPD draft, as I mentioned. There's some concerns about the 2 implementation. It's under a single vendor at the moment, and also some discussions about how the atoms are structured. The next likely action is discussion amongst the authors, the ADs, and the chairs to figure out the path forward, and we'll go from there. In the RFC editor's queue, we have the links and extensions for SRV6. That's a happy thing to get moving along. And also 7752 biz. Oh, let's get that shipped. We'll be so happy when it's finished. We also have Long Live Graceful Restart, finishing ISG review at this point. I think at this point it's waiting on the shepherd to help move things forward a little bit, so hopefully that will be done quickly. And we have 2 adoptions that are held in the pending state right now based on further review. We have the policy NRP document that's held for review versus another similar proposal. We're waiting to get feedback from the TEAS chairs as to what they have to say. They'll be discussing this space as part of their meeting this week, so hopefully we'll have this pop out in terms of actions soon. And very similarly, the M-binding document, we'll be talking to the spring chairs about how we handle moving that one forward. We do have an allocation list request from Linda for the 5G Edge Services metadata, and we'll get to that after the IETF. And as if we're not busy enough, we have all of the following things that are in the upcoming adoption queue as well. Clearly, we've had the CT and CAR stuff taking a lot of the oxygen out of the room. We're hoping that as we wind up this work over the the next bit of period, that it should go nice and smoothly, and we'll go from there. Just a very quick slideshow as we go through the different things we're going to be talking about today. My request is that if you are presenting today, be mindful about where you are on the agenda. Be ready to come up and present because we want to actually make sure people get their time slots. We will be now moving to Sue as a head up about routes with color.
So we're already 5 minutes late. Warning for the people at the end, which is V6, you may get moved to the end into the next section if we have a problem. We want to, the working group has clearly said that the CAR CT stuff is part of their desired focus, so we're paying attention to the working group. Okay, let's see if I can gain back a little. Just, when you're in the middle of the CAR CT stuff, you ask yourself, why are you doing this? So then rather than see this in both presentations, let me tell you what the chairs think, and then you can give feedback to us. BGPLU, it was there as a SAFI to carry IPv4, IPv6 with labels, and it also has support in AdPaths. Typically, it's used to carry the underlay routes, but it lacks support for intent, and we find that is really helpful in emerging applications. And more specifically, we wanted to see intent-based routing and forwarding. So that's where we started with this. Okay, where are we? We're in the middle of finalizing the experimental drafts. Please note, if you haven't commented on this on the list, support, non-support, we are looking for your feedback. We even have asked authors, and you will see the authors of the CAR draft being asked to comment on the CT draft, the CT draft being asked to comment on the CAR. We are looking for authors. Should you feel like you want to review, talk to me. I'd love to have a couple more reviewers. What do we have? We have CT that has run its a 4-week working group last call. It has 2 implementations. We had an excellent routing juror review from Ed and lots of reviewers. CAR's draft came out in its current form on the 10th of July, and we've had reviewers. We are still waiting for the reviewer from Ben Niven. Again, there are implementations. Please comment on that. We are looking for technical comments, editorial comments, and we realize that things have been done. And Andrew, we tried to follow along your suggested what's changed. Editorial issues, reorganization, SRv6, and there's a new NRI for CAR. The main question the AD will ask us as chairs are all the sections clear and easily implementable by experts. We want interoperable implementations. There is one new section in CAR. We need to ask the working group, do these new sections need review? Why do we ask? The implementation report does not contain these 2 new sections. We don't know how it's been done. We do hear rumors of implementations. Well, given that, hopefully I've caught up. Where are we going to go forward? We will run the working group last call until the end of the week. We quite frankly had an overwhelming amount of comments and support during the adoption. We're not seeing the same level during the working group last call. Please comment. We need the same thing. We'll judge support by the end. We were hoping to judge by today, but I'm not still as shepherding seeing enough. If there's enough support, we'll edit the draft and working group last call any changes. If there's not enough support, you've got to build the support, and we may again use an interim to offload this. Again, we're off now to the next authors. Jeff, you're going to have to help me with that one. Yep. New slide deck. It should be Carl. Swadesh, you're up.
No,
Nope, it's Reshma. Reshma. Now, everybody be nice to Reshma. It's her first presentation in IDR, so be a little bit nice. We want her a warm welcome.
Hello, everyone. I'm Reshma Das, and I'm from Juniper. Nats and I would be presenting the BGP classful transport status today. So we've done some really good work from March, the last IETF, and we just wanted to share that with you. So the agenda would be the current status. So we did an IANTEC interop test, so we'll be talking about that, and we'll see what's the next steps. So first of all, as Susan had projected, that we had got a lot of review comments, mostly editorial changes, nothing in the protocol procedures. So we want to thank all the reviewers. The document is in its current state because of all of your valuable feedbacks. I want to especially thank Sue for shepherding this document, getting us early reviews. It was really good, great work that we had pulled in the last 3 months. But during the IDR last call, there were some part 3 issues that were raised for both the draft. We just wanted to point the GitHub link that has those issues and parts of the draft that solves it. So if anyone is interested into looking into it, please, you're more than welcome. At this point, like Susan said, I invite more people to review the draft so that it will become more valuable for everyone. Currently, CT is under last call, and most of the last call review has been done, and we have finished the address the issues. But there are some 3 that is pending, and we are working on it. So you can find, like, for any IDR draft, you need an implementation report. So this is where you can find the BGP CT implementation report. So we have 2 shipping releases, implementation, both in shipping, Juniper since 21.1, so the first half 2021, and we also have the rare free RTR version mentioned there. Since CT has been there in the field for some time, we are having a lot of customer engagements, and they're trying out there in the labs. And we are very happy to announce that we will be hitting deployment soon. So in March 2023, we had the IANTEC interop test. At that time, we were under NDA and we couldn't discuss this last IETF. So we just wanted to say that we had this successful interop test. These are the Junos and free router models and roles. I'm just flashing it. We'll look into the topology in the next slide. Also, please find the link to the report. It's on page 36. It's a bit extensive report. And there you'll find the tests done, the topology in more detail. Also, we have a video which I will flash to the list that you can go through it. So in top high level, this is the IANTEC CT interop. As you can see, we have Juniper routers and P1 and P2 and ASBR2. So this is an inter-AS option C network. And ASBR1 is the free router code. So it plays an important role in both the control plane as well as the forwarding plane. So something new in the free router is like the BGP CT talking between ASBR1 and ASBR2, as well as in between P1 and ASBR1. It's the iBGP CT. So here we have the RSVP tunneling in the first AS, which is AS64512. And there we have both gold and bronze LSPs through RSVP-TE. And in the other AS, we use Flex and Go to interrupt. So, and there is a internet service traffic running between P2 and P1, which will tell the intent that they want, and CT provides an end-to-end intent-driven traffic. So as I said, I'll flash the YouTube link and you guys can go through this in more detail. So as next steps, we are requesting for like an RFC standard, and yeah, please. That's all from me. Thank you, guys.
So Ketan, we'll take a very quick question.
Yeah. Ketan Talaulikar, Cisco. I have shared the detailed review comments on the list. Just wanted to bring up one point, which is that the draft refers to a lot of individual documents which are not yet adopted by this or other working groups, and their functionality is required to deliver some of the things in the draft. So I just wanted to see if the authors would or the chairs would like to respond on how to deal. Similar comment was also raised by Med, I believe, in the RTG, his RTG review. Yeah.
Yep, this has been flagged. It's been discussed, and I'm sure that the authors will start helping us untangle this. Swadesh, reminder, please sign into the queue, but very quick, and
Quick
you're
comment.
stealing from your own time.
Sure. Yeah. Hi, I am Swadesh from Cisco. I think it was mentioned in the presentation that no protocol issues have been are still there, but I think I have raised about the protocol aspects of BGP-CT, and I'm still waiting for the churn aspect and the forwarding redundancy, and I'm still waiting for those responses. Thank you.
We will take it to the list. Like we saw your review comments. Thanks for that. But we'll take it to the list. We don't see it alarming. Thank
I
you.
think it's an ongoing conversation and it's a nice one. So maybe we can discuss more.
Swadesh, you're
Are you presenting or DJ?
Swadesh is.
Okay. The next slide is this one. Right back.
Yeah, hi everyone. I'm Swadesh Agarwal from Cisco Systems. I will present BGP car updates on the behalf of all my co-authors listed here. So this draft has been around for a couple of years, and we have a broad multi-vendor support as well as two interoperable implementations for this draft. So, so this draft has already been updated for MPLS and SRMPLS, and recently we updated it. We extended it for SRv6 for steering the BGP services over the SRv6 service SID, and for steering over the SIV service SID, the services draft says the SID could be routable or a non-routable. So as a part of the update for routable service SID, we have a SRv6 locator or the summary of those SRv6 PE locators as an IPv6 prefix, which provides reachability via the BGP car in the multi-domain network. Since these are routable prefixes and uses the native IPv6 longest prefix match forwarding, which is well known, as well as the locators can be BGP specific intents, or it could be a flex algo provided intents, which are shared with the IGP flex algos. And of course, as a well-known technique, it could be advertised from the border routers as a redist, or from the locators can be advertised as PE. And for the non-routed SID, as per the BGP services draft, it's an SR policy, which is an E-C, which we have already defined in the base as a base procedures. As an SR policy can be redist as a BGP car route. Not sure it's not going to.
I moved it.
Yeah. So since it's an IPv6 prefix, we can leverage the well-known techniques, routing designs, and that's what we have listed in this slide. It's one of the techniques is a hop-by-hop routing for the IPv6. The ingress Ps, the border routers, as well as the inner P routers learn and install the eBGP car SRv6 locators or the summary routes, and we don't need a intra-domain encapsulation in this routing model. And of course, the recursive resolution via IGP flex algo provides the intents to the eBGP next hop. Another well-known deployment model for the SRv6 is a encapsulation model for the intra-domain. So only the ingress Ps or the border routers will learn the BGP, the SRv6 locators or the summary routes. And the shared end SID of the BGP next hop provides the encapsulation to the BGP SRv6 routes for the given intent. And for the non-routed SID, which is in the base procedures, we distribute the SR policy, which is an E, C in the BGP car routes to the ingress P from the egress BRs. And underlay reachability to the egress BR is provided by the locator, which is again advertised as a prefix, as IPv6 prefix. And the recursive resolution. And of course, in this case, we don't need on these BR routers an E, C state. So that's the advantage of advertising a locator of a BR router in the underlay, in the BGP car. And the recursive resolution on the ingress P builds the encapsulation based on the sets. So, SRv6 locator is a one-to-one with the intent. So it's an IP prefix, it has a one-to-one mapping to the intent. So it makes sense to not add color to the NLRI. And therefore, as a basic data model, so we have defined it as an IP prefix. It's routable and installed in the IPv6 forwarding table. And we all are very well aware of these procedures. It's a same route processing semantics, which is provided by the RFC 4271 or 2545. It's IPv6 unicast. And it's consistent with the car semantics just for the color aware next hop, as well as SID selection, resolution over the color aware next hop, routing policies with the color, and of course carrying the AIGP because it's for intents. And an end-to-end route intent can be optionally carried in the LCM EC for the routing policies and for these selections. It's a complete reuse of the well-known BGP IPv6. It's just a separate SAFI for the operational reasons. And the use cases is, of course, as already mentioned, is for SRv6 locator distribution. And since CAR also supports the MPLS, it can be extended for the best effort transport path, just for the simplicity for the operators instead of running BGP-LU. So same SAFI carrying all the transport prefixes. So why CAR SAFI for SRv6 locator? Because it's a separate SAFI for the infrastructure prefixes. It avoids the overloading of the IPv6 unicast SAFI that carries the service or internet prefixes. An automatic separation of the routes, avoids need for the route filtering, a complex route filtering or for the separation, and enable the implementations to do a the infrastructure route prioritization in their processing. And these are the links for the working group production calls and our responses. And these are most of them been closed. And you can see implementation reports.
So please put yourself in the queues if you're going to try to go up there.
I would like to thank all the collaborators and the reviewers for the discussion and the comments, both on the list and past IETF meetings. And thanks for all the members for the support during the working blast call.
A reminder to everybody wants to step at the microphone, use the online tool to put yourself into the virtual queue. Kair's up first.
Kair Patel, Arcus. Speaking as a working group member, we have an implementation of this draft within Arcus. We've showcased the interoperability within our labs and at the last MPLS World Congress successfully. So far, speaking again as a working group member, we haven't seen any issues in the interop that we have done.
Okay, Reshma.
Sorry, I hadn't joined. I hadn't joined Miticho, so because I was in the room. Anyway, Kaliraj. So I have a couple of questions. One, for this SRv6 use case that you're talking about, we can just use LU.
Come again, repeat the question.
We can just use LU because it has the same kind of encoding. So when we use different mechanisms for MPLS based encapsulation and different mechanisms for SRv6 based encapsulations, some using color, some not using color, some carrying color somewhere else, and using LCMEC or color extended community. There's so many different variables. I think it will be better to have one common way which works for all cases.
So
that was one comment.
So as per the base model in the car, we have defined a a new SAFI, a modern SAFI just for the transport purposes. And it is carrying, it's made for the new set of encapsulations. We know as the encapsulations are developing, it is for MPLS natively defined, not like using BGPLU where it's only natively defined for the MPLS, as well as now we can carry natively SRv6 or any other encapsulation in future. It supports the migration for the operators easily, carrying multiple encapsulation, not breaking any of their operations today, like update packing and all those. So it's a modern SAFI with the inbuilt this. And why BGPLU? You know, IPv6 BGPLU is for the best effort path, and it is for natively for the labels, and it is being used for services also in the 6P. So we wanted to, since we define a new SAFI which need to be extended for the color for the MPLS case, it makes sense to carry the same IPv6 semantics. Nothing is changed. It's a well-known IPv6. It's just carried in the SRV in the SAFI as a new route to provide that prefix.
I welcome creating a new SAFI.
We get one question per time.
Okay.
So take the discussion offline.
Sure, we'll send the comments offline. Yeah. But another question was, in IETF117, you had mentioned successful interop at ENTech. Can we have a status update on that?
Yeah, so ENTech, we have to pull it down because of, I think we mentioned in the IETF, and as part of we were not aware that we cannot expose that interop. So that was the reason that was pulled. So, but we did just next to it, there was MPLS World Congress, and we did interop right then, just for the public sake.
Yeah, Keyur Patel, Arcus. Speaking as a working group member, 2 comments. We were actually shown as a successful interoperability at the ENTech as well.
Yes.
But for the reasons that he mentioned, we had to pull it out. Second comment, speaking again as a working group member, LU is a bad choice for this. Just because you can do it in LU doesn't mean you have to overload LU. LU has a semantics of using a global table. Really, intent will have a semantics of having multiple tables and ability to shard based on what intent is. And therefore, you are best suited to do this as a separate SAFI. Which SAFI is up for the choice, but keeping it outside LU would be a right choice as an individual opinion. Thank you.
Okay, thank you, everyone.
It's G-Done's turn.
Yep. G, you're up.
Hello, everyone. This is Jiedong from Huawei. I'm going to give an update about the draft on BGP colorful prefix routing for SRv6-based services. Okay, some recap about the CPR mechanism. This draft has been presented in IDR interim meeting. So here's just a brief summary of the key messages. First of all, the basic principle of the CPR is to make use of the SRv6 locators to represent the different intent or colors. So we can assign different SRv6 sublocators to represent the color or intent, so that we don't need to carry the color inside the NRI. And the SRv6 services can be allocated from the C space of the corresponding colorful locators. Then these colorful locators are treated as a colorful prefixes by BGP protocol. And the CPR mechanism, actually it's an informational document. It is a mechanism to describe how to establish the interdomain or intent-aware path for the SRv6-based service based on the existing BGP technologies. First of all, we are reusing the IPv6 unicast address family for the advertisement of the CPR routes. And the color extended community is used to indicate the intent associated with the colorful prefix in each network domain. And the resolution of the CPR routes to the intra-domain intent-aware path is based on the NetHop color tuple, which is the well-established mechanism in the BGP and in SR technologies. And with the CPR, we also have some advantage in the data plane because we can optimize the data plane encapsulation to reduce the encapsulation overhead. Because taking advantage of the IP reachability of the SRv6Cs, we can use IP longest prefix matching based on the services so that it can match to the CPR routes to steer the SRv6 services to the corresponding internal wire paths. And with this, we can remove the dependency on the dedicated SRv6 transport seed in the data plane so that we can have a better encapsulation efficiency. So here are some updates about the drafts in the recent versions. In the version 01, the changes are mainly some clarifications about the mechanism and the procedures when there are some of the transit domains are MPLS-based. So it does not only support the IPv6 networks, it can also work in a network with both SRv6, IPv6, and MPLS. It also adds reference to the SRv6 and MPLS interworking draft. In the 02 version, we add some clarification about the data plane optimizations with the longest prefix matching of the service seeds. We also revised the operational consideration section to clarify the relationship of this document with the BGP railways color extension mechanism in the working group. Okay, for the next steps, we believe the CPR mechanism is straightforward, stable, and well documented. It is considered that it is complementary to the BGP mechanisms with the new extensions for the railways color purpose. Okay, the CPR provides a mechanism which can be used for better interoperability and incremental deployment, which can be required in some of the network scenarios. At the same time, the BGP extensions with the new SAFI, NRI, or new BGP attributes could be introduced when required for other network scenarios. For the SRv6, at least for the SRv6 part, we hope that the data plane operation could be aligned in the different options. In the end, we think the document is currently ready for the adoption, so we'll ask for the adoption.
Thank you, Ji. So this document is intended for informational status, if I remember. So when we have the discussion, please remember that it will be in that context.
Hi, Andrew Alston here. Speaking with no particular hats on at the moment, I just want to ask, I've seen the term intradomain show up quite a bit in these slides, etc. And I would like the authors to give some consideration as to how they're going to address the correlation of that with the fact that SRv6 is explicitly a limited domain protocol. And there's going to need to be something around that, because using SRv6 across domains is actually a violation of the SRv6 standard.
Thank you, Andrew. We will add that to our set of things to check. This is a general question, a time for anyone who has questions about the general color section. As you can see, there's lots of discussion between the authors and other reviewers. I have about time for about 1 or 2 questions if someone has them. Okay, well, our agenda could certainly. If you have questions for the authors, I've asked both the CAR, the CTs, and the CPR authors to stand. Front of the room work for you guys to stand in case you have questions specifically for them. So G, if you have time afterwards, and no, not now, but after the thing, Reshma and Nats and Swadesh will be up at front so you can ask them questions. We'll go on then. Thank you.
So Ketan, did you have a question?
Ketan Talaulikar, Cisco. Not about CAR or CT, but a more general deployment design aspect about color-aware routing. So these are different multiple ASs within a same service provider context. That's what we are talking about. The service routes in inter-AS option C are end-to-end, and they carry a color ext com, so they carry a color. while we have a transport layer where the two proposals have, I mean, in a car it is still color, but in transport it is transport class TC. So if the services are end to end, and as my reading on both the documents say that the color is consistent, it's a single color space for the services across these multiple ASs, then I'm wondering why it could not be the same for the transport layer. Is the question this thing?
Are you addressing that to me, or are you
Oh
addressing?
no, I'm just
Good,
open
good.
question to the working group, right? So we have a color at the service layer.
Hmm?
In one proposal, we have color also at the transport layer. In other proposal, we have TC/color. I mean, they are used sometimes interchangeably. So we are saying that the service layer color has to be consistent, or if that's what I read, then why is it difficult to do it consistently at the transport level also? I mean, single namespace at transport layer. Yeah, I hope my question.
Yes, your
yeah.
question is excellent. It is, in some respects, an answer to Andrew's how do we see SRv6 in the multiple AS fashion? And I appreciate it. Ketan, do me a favor, send me the question specifically so we can track it on the documents. Thank you. Kalaraj, brief
I just
on
want
both
to provide
of
a
you.
brief answer for Ketan's question. So this was discussed during the part one, part two, and
Yes.
we have real world scenarios that our customers brought up where in real world, all the domains are heterogeneous. They are not homogeneous. So what is provided in CT is just a way where the heterogeneous realities in the real world can be deployed properly by having a homogeneous service layer, but the transport layers, they absorb the differences in the heterogeneous layers. But we can talk in detail when we respond to your comments.
Both of you can talk offline. Any other question? If you're brand new, no question is bad. At least giving us the question can allow us to go forward. Okay. If you're shy, come talk to us. Remember, we started out with BGPLU wanting to end intent. We're asking the working group, you're up to your whatever, and alligators, make sure we're doing the right thing.
Okay. Next presentation is Kaliraj. You have stolen from your own time.
Hi, this is Kaliraj, Juniper. So I'm going to present the status of BGP multi-desktop draft on behalf of our co-authors. Okay, so it's a quick agenda. I won't take much of your time. So I'll just present the changes to the draft since the last time it was presented in IDR interim in October 2022. And I won't go through the recap in detail, but I'll just provide it as you can just go through it later, if at all, just for reference. And we'll go through a few use cases that are coming up where customers are interested in using this and the next steps. Okay, so the main changes to the draft are some removals. Basically, we removed the propagation scope checker. The BGP attribute announcement draft solves this problem as a per attribute scope. And we thought it's better just stick with that instead of having a separate mechanism for this attribute as well. And we plan to introduce a per route propagation scope checker in future. That falls in place with the discussions that are happening with attribute escape. We feel that having a route escape propagation scope checker is better than attribute escape. So that's a discussion for a future day. And we removed the domain local preference thing that was there in the draft because that was addressed to address a scenario that is being taken up by OAD draft. So this keeps the MNH lean and confined to forwarding only attributes. And there are some editorial changes to make the draft look better. And I added some illustration of use cases that we're going to discuss now. And the IANA section is being reviewed and updated. So this is just a background of how we express next option in BGP. This was presented in the last interim. Here we just want to point out that we have cases that are getting added very quickly, like the secondary level attribute, which is going to be presented today. And FSV2 has some redirect to IP actions. So all these cases are like organically they are cluttering BGP in a way, and it's good if we confine them all in a scope of a single attribute where we can have them homogeneously work on all service layers, irrespective of whether it is IP, IPv4, MPLS, flow spec. So this is also just a recap of the problems. So here we just say why add path, what is the problem, and the other use cases. I'll just skip over this. So this is the bird's eye view of the multi-next hop attribute. Basically, it has multiple TLVs, and it just basically what we have is a forwarding instruction, which is nothing but a forwarding action and a set of arguments. And we have a primary path, which consists of a few forwarding instructions, a backup path, which consists of a few of forwarding instructions, and the label descriptor. So typically, an MNH will have just a primary path, and in some use cases, it may have the backup path as well. And label descriptor is for just signifying what is describing a label. So this use case is about just doing, you can say WECMP or ECMP for a region one. It wants to attract traffic towards the border nodes like R21 to R24. So in the regular way, we will just do add path of, let's say, send 4 feeds through the RR with the link bandwidth community, which is specifying how much traffic should come through each of these routes. And region 2, R2 will just do a multipath consuming the link bandwidth community. And so we see that the number of routes that we need to advertise, it's basically based on number of next stops we want to advertise. So it's like the rib, it actually becomes 4x. And this is a problem for the RR, which is having a rib out 4x, and for R2 as well, which is having a rib 4x. And these problems, some customers, they are interested in solving using MNH, where in MNH, the same thing can be expressed using one BGP route, where the MNH has a primary path with multiple forwarding instructions, which just says forward to the specific router with whatever ECMP we want. So it reduces rib out scale by at the RR by 4 times, and also reduces the lock rib because the same information is being carried by the same attribute. And this is a similar scenario for L3 VPN CEs. So today we cannot even express these things unless we use unique RDs and add path, which again increases the scale. So here the PE can express load balancing towards a multiple CEs by using the MNH, by just advertising multiple labeled next stops in the same BGP route. And this is the label oscillation avoidance problem. So here, whenever we have a multi-home PEs and per next stop label protecting each other, they can have label oscillation because they don't know which is the primary path, which is the backup path. So this can be avoided using an MNH where we can advertise a primary path as well as a backup path. And it just avoids the cyclic dependency between the PEs because label allocation doesn't depend on the primary path of the other PE. And the backup path is only used for the primary CE paths. So these are the few use cases that are coming about. And as we saw, we have other use cases like FlowSpec, which can also work based on that. So I think there's enough interest and details in the draft that we can work together as a working group to see whether it fits in. And so I request for adoption. And the next step is to work on implementation and attempt to solve these custom use cases. And we solicit more input from the working group, more reviews.
And with apologies, we are so far out of time that we can take no questions. So please take questions to mailing list. I'm sorry. Next presentation, SRv6 segment list optimization.
Can you hear me?
We can hear you. Do we need to drive the slides?
I'm Chan Wanlin from New S3C Technology. I'm going to talk about SRv6 segment list optimization. Next, please. First, let's take a look at the background of this draft. In the following scenarios, it is necessary to specify the end state of the egress node of the segment list of SRv6 policy. Scenario 1, steering traffic based on binding seed. Because the binding seed cannot be the last seed, so it is necessary to add another end seed for of the egress node outer the binding seed. Another scenarios end-to-end fast fold detect based on SRv6 policy. The end seed of egress node must be specified in the segment list of OM messages. For example, the controller dispute an SR policy to load P1 with the segment list information as 3 colon 3, 4 colon 4, and 5 colon 5. Load P2 advertise the end DT4 set to the load P1. When the P1 forward a packet to P2, the encapsulator as such had include both end set and DT4 set of P2. However, when the OM packet read check the newness of SR policy only contain the path information distributed by the SR-V6 policy. The sampling loader head of data packet forward based on SRv6 policy will encapsulate both the end seed and the VPN service seed of egress node. Next, please. This encapsulation will result in the following two assumptions. PSP behavior may not be feasible since the condition of SL equal 0 is not met, which means the penultimate SRN port node cannot remove the SH from the IPv6 extension head during processing. So the forwarding efficiency of the egress node decreases since the data packet will need to look up the local seed table twice. For certain chips implementing the second seed table lookup requires a loopback interface mechanism due to the bandwidth limitation and the possibility of other service packet being processing in the loopback interface. The packet forwarding efficiency towards VPNs will be greatly affected. Next, please. To resolve this issue, so we propose a simple and effective solution. When both end seed and VPN service seed of the egress node are present, the end seed can be removed while forwarding the packets. The control dispute a segment list via BBP and indicate which seed belongs to the egress node. It notifies the ingress node by extending the segment flag of segment type subtheories, and the ingress node optimizes the SH of the packets. When they are end seed and service seed of egress node on the path, the SH of the packet already contains the service seed of egress node. The end seed of egress node will not be encapsulated in the sec list at the same time. Next, please. Extend the segment flag of segment type or subtheory. We define a new bit to identify the seed, which is the egress node seed. E flag when set indicate this segment seed is egress node seed. Next, please. Finally, we take a look at a use case of our solution. Suppose the control disputes an SR policy to load P1 with a segment list. And the last SRv6 seed of the segment list has its E-bit flag set. In case of forwarding data packet to the VPN, The SH head encapsulation process will include the tail node seed. Only the VPN source seed will be included, and the last end seed will be removed. However, in case of sending OM packet, the subpolicy in entirely second list information will encapsulate in the packet. Next, please. That's all. Any questions, comments are welcome. Thank you.
Thank you. We have time for one brief question. There are no questions in the room or online. Thank you for your presentation.
Thank you.
Next presentation is OAD. Sure.
All right. Hi, I'm Kevin Patel, and I'm going to talk about OAD. I think Alvaro is somewhere in the room, right there. Fantastic. Next slide, please. So we presented these slides at the interim, and this is just a refresher for those who couldn't attend the interim. Here is the problem statement. Why are we doing this? Networks today have common administrative entity that spans across multiple autonomous systems. That could be by evolution or mergers and acquisitions and partnerships and whatnot. And typically when you cross eBGP boundaries, you lose attributes. And we want to have those attributes carried across different ASs to have a better control. This is predominantly for ASs under single administrative domain, not just random set of eBGP ASs. Yeah, next slide, please. So how are we doing it? We came up with a new peering type here. And this means we are not explicitly exchanging capabilities. Now, authors did talk about this topic to depth. We understand capabilities. However, just as you have eBGP, iBGP, Confed BGP, it seems counterintuitive to establish a session, exchange a capability, and say, nope, let's go over to an OAD-like fashion and leak attributes here. This is predominantly why we set up a new session type. And the second thing is, we would like operators to explicitly configure this without automating it, so both ends know what they're talking about from a session perspective. Happy to take this discussion at the over the email if you like, but there has been a certain method to a madness, just in case you're wondering. And then we've said, follow eBGP procedures for most part. However, try and leak iBGP specific attributes. When I say follow eBGP procedures, I'm saying do exactly what you do to ASPath, but also leak certain attributes as and when you need, right? That's what has been, that's essentially in a nutshell what this proposal is. Next slide, please. So what happens if you have a misconfiguration? Well, one side is going to assume eBGP and another side is going to assume eBGP OAD. But this is exactly what happens to 4271. In some sense, what happens if you have one side configured as iBGP and another side configured as eBGP? You go, session comes up, but then everything becomes OAV. The whole idea again here is that both sides, operators, have certain agreement, certain set of consensus before they go ahead and do something like this. Next slide, please. So what did we change in version 2? We did get a lot of feedback, and we have beefed up error handling as to how we are doing it. Secondly, the decision process has been modified a little bit. You typically have eBGP over iBGP. Now you have a new session type that you want to prefer that comes in. We've also added text for route announcements for this kind of a session, which means you do not exchange any routing information unless and until outbound and inbound policies are explicitly set, and they can be set, configured with null policies. That's totally fine. But since it's an eBGP session, the text does say, please do the needful. And last but not the least, we have added text to the deployments section explaining what are the possible use cases. These are next steps. Please provide comments. More comments are always welcome. And we would also obviously request working group for an adoption since there are use cases. Questions?
Care, oh, I should go to the mic.
You're in the queue.
You're good.
Okay, I'm in the queue. Care, just a little background from history. Um, some of the things you're describing come from the original uh, confederation design in the ISO work, that we found this was a necessary concept. The AS confederation in the Cisco implementation was less than full, is a polite way. And so I think that you're hitting on something that we really do need to solve. There are problems if you don't insert some sort of marker, but we'll pick this up online. I find this very interesting work that harkens back to some things we found originally.
2 quick points to that. Thank you for the feedback. For issues to a vendor, I think Swadesh is sitting there. He's to be blamed. And he's smiling. So we'll beat him up. And the history lessons.
Oh no, it's Paul Trina. We won't go any further.
And the history lessons, I am sure Alvaro is making notes on that. Thank you.
Thanks, Kayer. Linda, you are the next 2 presentations. If you have any ability to help us recover time, it would be gracefully appreciated.
Thank you. So I'm going to give an update on this 5G edge service metadata. How do I move forward? This one. Sorry. So some of the recap, if people didn't listen to the last presentation. So the key points of this 5G metadata is really in the 5G domain. When the traffic come from user UE comes through the UPF, it can ingress into the IP data network through different ingress nodes. So for the ultra low latency services, they not only require the least, the fastest path, the shortest path, but also would like to be processed at the site with the shortest processing time. It is under the assumption many services, especially those low latency services, have multiple instances instantiated in different edge data centers. So a couple of key indicators to indicate or predict possible service delay at different sites. One of the attribute matrix, we call it site availability index. This was to indicate, like in one data center site, edge site, there could be one pod or one floor or one row of server racks. They may lose power. So when they lose power, all the service instances are impacted. So instead of the egress router to send many route withdrawal messages, is reduced into one single message to indicate every route associated with this particular site ID are down or withdrawn. So that's the purpose of this site availability index, which is represented as a percentage. 50% or 0%. Bear in mind that site here is not referring to one location. It's really referring to a group of a pod or maybe multiple services associated with one server rack. Second is we call the preference index. The preference is really associated with particular service ID. Some services may require high computing power. Some services may require higher bisectional bandwidth among all their microservices. Some services may require like a huge storage service. So based on the property of each edge site, so different service ID can have a different preference index. And preference index is also used to achieve sticky services, stickiness, meaning that when UE migrate roaming from one cell tower to another cell tower, if they do require sticky service, and that preference number, a preference index can be utilized to achieve that purpose. And then one change we made in this draft, in this revision, is we changed to the service delay prediction. So the ideal case is to find the edge data center with the fastest processing time. But it's very difficult to predict which side has the fastest processing time. So for this prediction, value can be a configured value, like controller can configure a service delay prediction on different sites. Could be also measured, like based on the remaining available resources. And for a certain environment where the network operator don't have access to the detailed application status within a particular site data center, they can also use historic data to predict possible service delay based on the principle that, say, if historically is this much data towards a service ID, suddenly it could be 200% increase. This could be because a particular convention is happening at this particular cell site, so attract lots of user device roaming into that site. So based on those, compare with the historic data, it can use that to predict the service delay. So those are the three major things we changed in this revision.
Your 4 minutes of your 5 minutes.
Oh, okay. So I will just accelerate it. This is that availability index is really to deprefer a path to a set of routes. So main thing I would like to get feedback is on this IANA registry. So we requested a metadata path attribute, and underneath this path attribute, there will be many subtypes being defined. Right now in this draft, we have specified 4 subtypes, and with CAT's working group coming up, defining more matrix for different environment, there could be more be considered or be added. So the registration procedure here we recommend is expert review. And so that's the end. We would like to get more comments, and so please come to us with at the end of the session and give us comments or suggestions. Thank you.
So Linda, you have another presentation that you have a very short time for. Do you want to take a question or defer it?
Do I have time for questions? No?
Okay, so Satya, we're going to have to defer the question to the list. Please send it to the list.
Or come to me. So this is the flow spec. This is an even smaller one. Is we call it transport network aware mobility. So background, in the DMM working group, there's a draft to mapping service into different slices within the 3GPP core, basically from the G node B to the UPF. And based on the application service characteristics, they assign them into different network slices or pieces. So in the RTG working group, we have a draft to extend that characteristics into the IP network. And here, I try to make it quick. In the IDR is really, we want to utilize the flow spec to be able to pass the policy into the ingress node. So there are already several available drafts, working group draft on the redirect. Actually, some of the authors here, I would like to ask, some of the drafts have been expired, and hopefully you can renew it because that would be needed by this TN aware mobility. Here we are adding 2 things. One is to redirect into the SD-WAN IPsec tunnels. This is based on assuming they're already redirect to the IP path and also redirect to the IP particular address. And also we want to add new IANA attribute, which is a non-transitive extended community to redirect traffic into different to the IPsec security associations. It's not listening to me. Okay, so this is basically the new subtype sub-TLV we propose for the flow spec redirection to the SD-WAN tunnel. We're using the IPsec Security Association ID as an indicator for the tunnel ID. That's it. It doesn't work. It doesn't listen to me. Okay, so so here we want to get more feedback, and afterwards we'll ask for working group adoption. Thank you.
So the chair's gonna, the next presenter can come up, but Linda makes a really good point. If you were one of those people who have a draft on FlowSpec, the implementations on FlowSpec v2 are said to begin shortly. Please give me your feedback on these drafts. If they've sat after a while, I will just turn them into not used because I've been asking for 3 or 4 years if you're still interested. So if you're on an individual draft and you still want it, if you're on a draft that hasn't updated in a short time, please, as a chair, I ask you to do that. Thank you.
Hello, everyone. I'm Yao Liu from ZT, and I'm presenting this draft on behalf of the co-authors. And this draft proposes extensions to BGP to provide segment list protection within candidate paths. And it is an optional fast reroute mechanism, aims to provide a flexible protection relationship for segment lists. And this draft are trying to be consistent with the extensions in the BGP draft for segment list, for backup segment lists. And maybe it can be used in scenarios like load balancing, for example. And the segment list 1 and segment list 2 in the primary candidate path CPU1 together provides a bandwidth for 80 BPS, and if the segment list 1 went down and the CPU1 is still active, but it can't carry the bandwidth about 80 Gbps. So if there's a backup list, for example, segment list 3 for list 1, it can take over after segment list 1 fails. So this candidate path can still fulfill the requirement. And here are the updates since 112. And we add a potential use case, as we mentioned in the previous slide. And the extension for segment list ID is removed and merged with draft link, and leave this draft focusing on the list protection part. And the protocol extension part is adjusted accordingly. And we add Changwan Ling and Michael Treff as co-authors. And here's a quick recap of the expansion. And we add a B flag in the segment sub-TLV to indicate that this segment list acts as a pure backup path. And the list protection sub-TLV is defined as a sub-TLV for the segment list sub-TLV. And it carries the segment list of the backup segment. It carries the list ID of the backup segment list, which can be delivered via segment list identifier introduced in draft link. And that's all. We request review and comments.
Ketan Talaulikar, Cisco. So within a candidate path, all the segment lists are supposed to be for load balancing purpose only. Only using it for like active backup violates the SR policy architecture. So I think this is, I mean, if you want to do active backup, then that's between candidate paths, not at the segment list level. If you look at the PSEP draft that you referred to, that specifically says that this multipath backup is not applicable for SR policy. So maybe you can take a look and. Yeah.
Okay, I'll go back to check that. Thank you. Okay, and this draft is about this draft analyzes this draft analyzes the problems may be encountered when you implement the SRv6 based BGP services in the SRv6 and MPLS coexistence scenario and the possible solutions.
Is this the wrong presentation?
Yeah, I think it's slide, previous slide.
Service capability. That's correct.
Oh yeah, and this is a correct slide. Thank you. Yeah, let's continue. And IFC 9252 specifies that how BGP messages are carried between PEs can carry SRv6 services to form VPN services. And it leverages the existing AV service of MPLS-based services. And the SRv6 service set is carried, or part of the service set is carried in the SRv6 service TLV within the BGP prefixed attribute, and which are attached with the MPBGP NLRI. And there are two types of encoding of SRv6 services. The first method, the SRv6 services, is encoded as a whole part in the SRv6 service TLVs, and the MPLS label fields of the NLRI is set to implicit none. And the second method, only the locator is carried in SRv6 service TLV, and the function and argument part are carried in the MPLS label field of the NLRI. And the coexistence scenario is shown in this slide. And P1 is a legacy device, and it only supports MPLS VPN. And on P3, both SRv6 and MPLS VPN are configured for the same service. And on the control plane, MP3 advertise both the SRv6 VPN route and MPLS VPN route to P1. And P1, because it's a legacy device, it can't recognize the SRv6 service TLV, so it may discard it and treats the SRv6 based route as an MPLS based route. So there are maybe two MPLS VPN routes for the same service in P1. And on the data plane, P1 then may choose a wrong route and use the label field in the NLI of the SRv6 route as MPLS VPN label and for encapsulation. And P3, when receive the packet, it may send the packet to the wrong service instance or just drop them. So to avoid these problems, and IFC 9252 specifies that implementations must provide a mechanism to control advertisement of SRv6 based service routes on a per neighbor and per service basis. Of course, we can do this by configuration. And but first, you need to get each piece capability for SRv6 based routes, and then you need to configure OMPs and service hours based on their capabilities, and the configuration is per neighbor. So this method has several disadvantages, especially in the large-scale networks. First, the per neighbor configuration needs to vary with the device capability, and the additional steps makes it more difficult for troubleshooting. And the last one, since there's no standard for the for to for the network operators to get the each piece capability. So there may be possible interaction problems among multiple vendors. And to control the route without per neighbor configuration, this draft introduced a new capability code for SRv6 based BGP service. And a BGP speaker must not send any update message that includes the SRv6 service TLVs unless it has sent the SRv6 based BGP service capability in its open message, or it has received the SRv6 service capability in the open message from its peer. And like any other capability, BGP capability codes, if the capability for the SRv6 based service is enabled or removed, an established session needs to be reset to resend the open message. And with this extension, and the service routes can be controlled automatically, and it is easy to implement. And this is the problem we encountered during our employment, and we think it's an easy solution. And since although this is we submit the draft in BES, but it's proposed extensions of BGP. So we present it here in IDR and request feedbacks and comments. That's all. Thank you.
Do we have any questions? Thank you for your presentation. Ketan, you're up.
Ketan Talaulikar, Cisco, presenting this on behalf of co-authors. This is an update to the BGP-LS draft for SR policy advertisement. Just a quick recap, you see the version 001, but this is an old document that we split out. And the focus now, this presentation is on the SR policy advertisement. This is a quick summary of the updates. It was also shared on the list. In the interest of time, I would not really drain all of them, but call out something key, focus on that. The main, I'll just jump ahead. So the main thing which I wanted to bring to notice is that what's been added in this spec is the advertisement of SR policies from PCE. So far, all the advertisements were from the head-end node via BGP-LS, but we've got some feedback that there are deployments which use PCE with PSEP, and it would be nice for the PCE to advertise on behalf of the head-ends. So that's really what's new or added in this version. This also required some clarifications or tweaks to specify what are the descriptors and what they mean. So I mean, all of this is in the draft. Just a note, this does not affect the existing functionality of advertising from the head end. So there are no backward compatibility issues there. And for the identification of the PCE, that's done via TLVs in the attribute, not in the NLRI. The next steps, so we have been receiving on the list quite some good feedback also off list. So please continue the reviews. Post this IETF, after waiting for some more feedback, we'd like to request for the IANA code points for some TLVs that are not been allocated. And once that is done, then we'd start preparing the implementation report. So hopefully sometime soon, we should be ready to go to working group last call on this. We understand that there may be lots more things that get added, but at least the base can progress. Any questions? Okay. Yes.
Hi, this is Gargi. So one question, I'm curious as to why you didn't consider putting it in an NLR and adding
Okay.
it all to the attributes.
So only thing which is added is the PCA identification. Generally, there will be at least redundant, like a pair of PCs redundant, and they would be advertising on behalf of head ends. If they put their advertisement, then we get two copies of the BGP routes from a BGP perspective. So that's just doubling or maybe even tripling the scale. So doing it this way, within the BGP itself, they would get collapsed. Just one will get advertised out. Yeah. Okay. Thanks.
Thanks. Ron Chen is next.
Good afternoon, everyone. I'm Ryan from ZTE. Today, I would like to talk about validity of SR policy country pass on behalf of all the crossers. Next, sorry. SR policy architecture are specified in RFC 9256. SR policy comprises one or more country paths of which at a given time one and only one may be active. Each country path in turn may have one or more seed lists of which one or more may be active. When multiple seed lists are active, then traffic is load balanced over them. However, a country path is valid when at least one seed list is active. This country path validity criteria can't meet the need of some scenarios. A draft transparent SR policy CP defines the validity control parameters and country paths to control the validity judgment of country paths. This document defines an invitation to BGP to distribute validity control parameters of a country path for a SR policy. This is for motivations. The country path validity criteria, which is defined in RFC 9256, can't meet the need of the following scenarios. For example, the country path one carriers a total of 200 megabytes of traffic within the policy one. The flow-based hashing always each segment list with a ratio 5% of 50%. That is, each segment list carry 100 megabytes of traffic. And this time, if one of the segment list is invalid, the remaining segment list can't carry 200 megabytes of traffic. However, the country path one is still active. This is the definition. We define the new SR policy sub-TLV. The new SR policy encoding structures with CP validity sub-TLV is expressed as below. This is the format of the CP validity sub-TLV. It mainly includes two parameters. The first one is valid segment list, valid SR quantity, which it indicates the minimum number of valid segment list and the active activity paths. 0 indicates no requirement for SR quantity. 0xFF indicates that the activity path is considered valid only if all the segment lists are valid. The second one is valid SL weight. It indicates the minimum value of the sum of the weights of the valid segment list and the active candidate path. Next comments, welcome. Thank you.
Jan, quick question.
Yes, just a quick question. I believe some operators, implementations already have a validation check, I guess, built into the implementation. So how would this interoperate with what vendors are already doing today? Thank you.
The question is how does this interoperate with features that vendors have that are already like this?
Okay. Thank you.
So again, please repeat the question to the list for all the time and having comprehension issues. Thank you.
Sure, sure.
So I will be the next question, next presentation. This is BGP over quick.
Jeff Haas is an individual contributor presenting on behalf of Alvaro, Yingzhen, and Chunglong, and Jeff Dansura. The rest of you hold up your hands so people will see. In the interest of trying to recover our time, I'll request that we defer questions. If we have any time, we'll take a question. If not, we'll be available after the session. So first of all, background for quick. Most of you who have actually been looking at things in IETF know it's a new protocol. It's a transport, runs over UDP, has properties that are low latency. It has encryption built into it, certificates, things that we all love from TLS or maybe hate. And most importantly for this presentation, it supports multiple streams. And it's the streams that we're going to be talking about here is the primary thing. A thing I'm going to note as part of this presentation, we are in our specs at the point of having good discussion about what we want the shape of the feature to look like. Significant numbers of details are yet to be filled in. We're happy to take input, but we are going to fill them in. Question is, why would we even be thinking about this? Well, my career, I've run BGP over any sort of weird things that happen to have properties of a stream session. Quick is just the latest of these things, but this is also a chance to do something a little bit different. So what we're really looking at is actually multi-channel BGP, where each channel can be successfully reset asymmetrically. And the consequence of there is we are hoping to get better resiliency for BGP as a protocol when run over this transport. We already have extensions that let us do some of the things here, at least specified. Some of them had to fit prototype or deployment, and they haven't been popular for various reasons. The ones that are relevant is the multi-session, which the implementers apparently were unhappy about because of the fate sharing not being in the same connection causing issues. And of course, we have dynamic capabilities, which also allows us to add or remove things and hasn't been popular for whatever reason. We're also looking at the fact that we get enhanced security out of here, the symmetric security that we get out of AO and MD5. They're certainly enough to make a lot of the operators happier than they used to be. The security folk are still not quite thrilled with them. And eventually things that we're interested in as interesting scenarios that are maybe for later is quick supports connection migration. So perhaps we'll have interesting applications where half of BGP can move its endpoint. So very quick terminology, and I kind of blast my way through here, but the really important thing out of this is that BGP over quick is about what we're calling channels. The way to think about a channel is an instance or half instance of a BGP state machine. Again, the details of what we're doing to the state machinery will be discussed in detail next round. But the relevant part is, if you know BGP, you largely know how this works. We're only doing some mildly kinky things to actually get the job done. So we do the basic thing. We're going to establish TLS connection over quick. We're going to put into it that we want a specific ALPN, and BOQ is what we're choosing to use. We're also suggesting that we don't put anything else on there. Although our conversation last night suggested maybe it might be interesting to do other things like RPKI. We'll have conversations about that later. And once we got the transport session up, what we're going to do is we're going to establish two classes of channels. The first one is the control channel. It is bidirectional. It resembles a standard BGP sessions in many respects, but really what we're doing, aside from the fact that it's special about stream 0, is that it's going to carry in its open messages the box-to-box capabilities. There are no address families that are intended to be exchanged. These are not carried over the control channels. So things like the role capability, your AS number, all these other things that are appropriate for the box-to-box communications, the box-to-box hold timer for the connection, those are passed around. Everything else is going into function channels, and these are effectively per AFI, per SAFI. There's expected to be one any given direction at a time. There'll be a violation to have more than one of these things. Quick allows us to do bidirectional and unidirectional streams. We are doing unidirectional streams in this case, and they can be initiated by either side. And we're going to allow for, as I said, exactly one per AFI SAFI. They are asymmetric. This means that we can have things like BGPLS being a write-only protocol, and you don't have to have anybody send you anything back the other direction. But also, it allows you to do the exact same thing for something normal like IPv4 unicast for the internet. You have unidirectional sessions. What this means is, one of the consequences, if you lose or have an error on one side, swapping 1 million routes on the internet these days, you don't have to take down both sides of things. This is the property for resilience that we find interesting. In terms of what we need to do, this means that our TCP-like framing has to change a little bit. But this is in the notation that they like out of the Quickland. And basically, the easy way to look at this is we're throwing an extra TLV wrapper around a standard BGP PDU. BGP unchanged is hiding on the inside of all of this. This is a thing that we're trying to do. Change as little BGP as possible. Some of the conversations we're going to have is, are you really doing BGP 5? Well, let's have that conversation as moves on. But for right now, think about it as weird BGP 4. And either it's a control channel, and you have an extra field in there to choose who you're addressing across the control channel, or you have just a function channel, and this is for an AFI-SAFI. This eye chart for the actor diagram is largely what we've just been discussing. Our first 4 lines are the standard bidirectional build up a standard BGP session bidirectionally. Session comes up. A lets B say that I want to do IPv4 unicast. When you're actually sending things in the initiating direction, the active side, it goes across the stream. When you're replying to something that is a unidirectional thing, you do that on the control channel. The general idea is anything that is intended to be a response from a passive portion of a state machine just passes over the control channel. Beyond that, it's standard BGP. It's pretty straightforward. Same thing for channel resets notifications. We're going to always do that on the control channel. Questions start becoming interesting, things like the hold timers. What do you do about that? We are going to use the control channel for standard box-to-box hold time. This means we get all the usual properties we want in terms of, is the box-to-box up? But we're also going to be making recommendations that the per AFI-SAFI function channels have a much longer hold time, in the sense that maybe you want to, just like the send hold timer and stuff, you want to see that the AFI-SAFI is still alive. We'll have more conversations about the details of that in the future draft. One of the things that we're going to do up front to enable work for later is we're going to throw a capability in there in cases where the box wants to take a specific quick role as either the client or the server. And for the most part, for standard BGP connections, it's going to be the any role. We're not expecting anything weird here, but let's say that you want to be the client because you expect maybe in a situation where you have a fabric, your server is a fixed piece of hardware, and maybe your clients are virtualized hosts that are popping up that may want to have some level of mobility across virtual machines. Quick allows this sort of thing. That's a nice feature. That mobility also indirectly talks about another feature, Quick, that's very fascinating for us in BGP operations land. You have the ability to reestablish connections that have been interrupted. So one of the things we'll be looking at is a restart type scenario, maybe where we temporarily lose connectivity. Has it been a short enough period of time? Well, rather than gracefully restarting, we just simply keep moving along as if nothing's happened. So to-dos, like I said, there's a huge amount of work for us to fill in the gaps for. This presentation is just to socialize the high-level idea that we're providing encryption, that we're providing these half duplex sessions, the fact that we're getting resiliency out of it, that we're enabling connection migration, things like graceful restart get to be interesting. We're going to talk about that, session resumption, all the operational considerations about certificates that are making some of you go, what the hell are you thinking? These things are crazy. But that said, we have people that are really good about PKI type stuff that will help us work through the profiles that make sense for the different deployments, and how do we actually share the certificates for environments where maybe it's a little bit tricky. Maybe these things get posted in RPI, for example. We'll discuss those details later on. Meanwhile, this is to get you thinking, maybe salivating at the idea of new features. So the next steps, we do actually have a GitHub where the stuff is happening. Most of the authors are in the room here. We have, I think, maybe a little time for a question or two. And if so, feel free, but please talk to us after the fact. We'll be working on the details of this and heading towards the point where it's specified deeply enough that hopefully we'll get prototypes. Questions, please.
Yeah, I'll go quick. This is Keyur Patel, Arcus. I'm not speaking as an IDR co-chair. I'm speaking as a CyberOps co-chair. Maybe you should consider presenting this to CyberOps too at some point because of the security implications that you could probably help solve.
Okay, and actually a relevant point to raise outside of the BGP-ish CyberOps type thing, as best I'm aware, we don't have control protocols in IETF currently making use of QUIC. There's a chance that the conversations we're starting here will have broader IETF impact. So please, those of you who do broader work across the IETF, be thinking about that too. Linda.
Okay, Linda Dunbar from Future Way. So this is interesting. So you can create multiple sessions. My key question is, how is it different from I create multiple BGP sessions? One session for control, whatever configuration, a box, another session, SAFI. So how is that different from there?
Right, so it was partially addressed earlier. So the BGP multi-session feature, which never got popular. The problem is that the connection layer does not share appropriate fade if they're completely separate. A TCP, the things do not coordinate with each other. The timers do not coordinate each other. Whereas within QUIC, the connection is controlled from inside of one black box that is QUIC itself. So that's the primary answer to you.
Thank you.
I think I'm next, Andrew, and then David Lampeter, if I pronounced your name terribly. +1 on CyberOps, +1 on looking at the difficulty for the state machine and the error handling. Big problem, coordination of the error handling. John Scudder and all of us can talk to you about what failed in the multi-session. All worthwhile, glad to help.
Who's next? David.
If you could go back to slide 10, 3 slides. Just to confirm the third point, the delivery order, you are considering here what happens if things race past each other that previously would be ordered by it being on one session, right?
Yeah, prioritization is one of the strong discussions that the co-authors have been having. Juniper's implementation, for example, allows for a very robust prioritization mechanism that currently goes through a single pipe and therefore has the properties you're thinking about.
Okay.
Once we go to multiple streams, we lose that a bit.
I'm concerned you're calling it prioritization because I would call it serialization, which is much stricter of a requirement, but it's kind of the same thing. So, okay, I'm happy you're evaluating how to do this.
Yep, we're totally thinking about it. And what's actually interesting more than the prioritization in terms of the sending side of serialization, a QUIC receiver gets the chance to choose which streams it's pulling from. So this is a stronger conversation than we'd have for even standard TCP.
Andrew here from wearing no particular hats. I just wanted to +1 your TLS considerations and just, listening to this as an operator and having seen the outages caused across the internet by some guy who forgot to renew his certificate, the idea that a certificate expiry could take down lots of BGP scares the hell out of me.
As it should.
So yeah, like I said, just thank you for that. And please give that really serious attention.
And sometimes that might be a feature. So we do understand that that is on the list. If you don't pay your bill, you don't get your cert renewed. And of course, cert rollovers will be part of our discussion.
Studies on ZTE. I think it's a whole new idea, and I think it may have any challenges. I think the most advantage is that the BGP session won't be expire anymore, because keep alive message can be conveyed from the control channel, right? So, but I'm worried about if the because the control channel is different from the update channel, right? So, what if the control message is delivered correctly, but there is congestion in the update channel? Maybe because we know that the quick advantage is that it can be split many channel, and it can move, and there is any congestion in it. So I think it has many challenges for it. And the other thing is that we think that it may change the interface between the TCP and the BGP, right? So it's a brand new interface for it. Yeah,
Absolutely.
Yeah.
And your points actually go into the prior discussions about prioritization. You know, in terms of the draining capability, it's possible that a receiver may completely stall address family either by bug or by purpose. This means that we'll be looking at functionality like the send hold timer as a thing that we'll be discussing. And the second sort of piece of that is that starvation in general is going to be far more of a discussion as part of this, because quick, you are responsible mostly in most implementations at user land to make sure that the state machinery for the streams is taken care of. So there's a lot more active participation in how the packets get moved around than there would be in TCP.
Jeff.
Yes, I like it.
Are we out?
Thank you.
Yeah. Thank you.
Tony, we have to defer the question if we can.
No, just want to clarify that there are keep alives going on the F channel. So Jeff was basically lying, as he always does. Okay, but that's correct. We were thinking about, the spaghetti problem on the Fs.
Did I make it 12? Zhongfeng?
Hello, Jeff, can you hear me?
We can hear you. Would you like to drive the slides, or shall I?
Yes, please help me to browse the slides.
Okay. Ready?
Okay, yeah. Hello, everyone. I'm Xie Zhongfeng of China Telecom. Thank you for giving me the opportunity to give this presentation about MP-BGP extension and procedure for IPv4 IPv6 mapping advertisement. Next, please. Yeah, with the global deployment of IPv6, transition to IPv6 only has been an important trend. During the past, several IPv6 only standards have been designed in IETF, but we found that BGP for IPv6 only transit core is still missing. So this document defines MP-BGP extensions and the procedure for IPv4 service delivery in multi-domain IPv6 only networks. It was firstly presented in IETF 116. The current version is 03. It should be noted that the existing approaches such as FC 55, 65, and FC 6992 mainly focus on a single domains. This has been discussed in the mailing list. Next, please. In this draft, we propose to use existing IFA-SAFI compilation to identify the reachability of IPv4 address block in IPv6 networks. Based on the comments received, we also consider to apply for a specific SAFI value in the future, but this needs further investigation. The NLR field is composed of IPv6 mapping prefix, the original IPv4 address prefix, and a series padding bits. Next, please. In addition, we add A new BGP path attribute that is FORMAP6 are proposed. It is in conjunction with the FSAFE for transferring IPv4 IPv6 address mapping rules in IPv6 only networks. It consists of IPv6 mapping prefix length, forwarding type, and address origin types, and IPv4 origin AS number. The attribute is optional and transitive. Next, please. These are the new revisions since IETF 116. Lots of comments have been received from Robert, Jing Rongxie, Jeff, and Essie. We really appreciate that. Based on the comments, Jeff has a ATDR set attribute of FC 1963-68 can be used for transfer the original IPv4 BGP routing in IPv6 networks. This has been added in section 3.2. The use case of IPv6 only data center for AI fabric is added in the appendix. Editorial change has been made also. Next, please. Yeah, the BGP extension has been implemented in routers with which we set up a IPv6 only testing network. The network consists of AS1, AS2, AS3. The edge routers such as P1, P2, and P3 and the P router are located at a different AS. P2 is connected to IPv4 Ethernet. Each P is configured with different IPv6 mapping prefix. Next, please. In this test, P2 learns IPv4 routing from IPv4 Ethernet, then generates the BGP NR, which consists of the IPv4 address block and the local IPv6 mapping prefix. The FORMAP6 attribute is generated as well. Then the mapping rule is announced in BGP update to IPv6 peer routers. The red figure shows that the P router received the IPv4 embedded IPv6 route. Next, please. Yeah, this is about the FORMAP6 attribute. The picture on the left is a BGP update message capital P router. The red box is FORMAP6 attribute, which is 6 bytes. The table on the right shows the meaning of each field of FORMAP6. In this case, IPv6 mapping prefix length is 1696, and the forwarding type is translation, and orange type or address origin type is local. Next, please. Yeah, the BGP information continue to spread. When P1 receive a BGP update from its label, they will validate the received BGP update by finding the FORMAP6 attribute. Then, based on the information in MP-rich NR and the FORMAP attribute, it restore the mapping rule with the IPv4 map prefix, IPv6 mapping prefix, and other information items. Next, please. We have tested this approach in the case of Nexus 4. Cases in traditional Nexus 4 deployments, upstream trend call is usually dual stack. When this new approach is introduced, the function of Nexus 4 and the FORMAP6 can converge in PE. The going and outgoing phase are both IPv6. End-to-end IPv4 service delivery over IPv6 can be achieved. IPv6 hosts can ping IPv4 internet servers in the test network. This test has shown that this approach in this draft can work. Next, please. Next step, we are looking forward to receive more comments and suggestions and making further improvement to this document. We also like to ask for working group adoption of this draft. This is my presentation. Jeff?
So for adoption, we will take the question to the list. My request to you is to send a formal adoption request to the list, and we will take it from there.
Okay, thank you.
We have time for a question or two in the room, if there's any. There are no questions. Thank you for the presentation, Chongfang.
Thank you, Jeff.
Last presentation is from Guyan.
Yes.
Thank you, everybody, for getting us back into schedule.
Can you hear me?
We can hear you. And just before we get started, this is a last request. If you are in the room and you have not signed in via the virtual blue sheet, please do so. We would like to get a large room again. Thank you.
Okay. Hi, my name is Guyan Mishra with Verizon, and I'm presenting the 4P draft on behalf of co-authors. Next slide. So today what I'll be providing is an update to the 4PE draft. So the main update to the draft is the requirement for using explicit null signaling. So that's MPLS QoS RFC 3270 to use pipe mode for using explicit null signaling versus an arbitrary label for the topmost label. And the reason for that is what that does is it gives flexibility to have the service label be either labeled or unlabeled, as well as because we're carrying v4 prefixes, so v4 NRI over a v6 next hop using PHP mode. If that was used and it wasn't a requirement, once that topmost label is popped on that PHP node, the package would be dropped. So, and thus the requirement for the explicit null. There was some other cleanup that I've done in the draft, and I believe the draft is ready for adoption. Next slide. So this is just a quick update, and I'll provide an email on the mailing list of a summary of updates to the draft, and thank you very much.
Well, thank you for an efficient presentation. Are there any questions in the room or online? So there are none. Thank you again. So this is a reminder that this is session 1 of 2 for IDR. We'll be meeting again tomorrow. So we will see you there.
All right.
Thank you, everyone.
Thanks.
Well, we don't have any strong time, but if you think about some of the virtual